Okay. Well, Happy New Year, everybody. Welcome back to the Quick Pass session. We're in session 6 now, and we are going to go over the last real data type or data collection, if you will, before we move into some other more advanced topics, which kind of cover the same stuff, just a little more advanced, of course. So we're going to go over dictionary sets and then their built-in methods. And the biggest difference between this data type that we're going to go over and the data type we looked at last week, which was lists and tuples, is dictionaries and sets are unordered. So there's no inherent order in memory to this data set. So when we put data in there, it's actually accessed via keys. With dictionaries, keys and values, and then with sets, they're just keys. They're a hashable data type, which means you can do all sorts of stuff with them. You can like encode them and send them over, and then decode them. But they're really powerful, and you'll see that dictionaries kind of look like, if you're familiar with the language of the web, JSON, it looks kind of like that. It behaves a little differently, so we're going to go over this and kind of just dive a little more. I've already exposed you a bit to dictionaries. We kind of covered it briefly. We're going to go into a little more detail with some of the methods in there, and then look at sets as well. And then we'll conclude. And then, during the last part of the class, we'll have time to go over some exercises, maybe look at last week's exercises if you'd like. And so without further ado, let's go ahead and get started. So we'll start with dictionaries. And, when we briefly went over dictionaries, we kind of talked about instantiating dictionary. Do y'all remember how I would be able to just define an empty dictionary? Okay, so we're getting some different answers. We have like square brackets and curly brackets. Yeah, and so in case you remember, is that I talked about the curly brackets, and I said, it has to have a colon inside of it. So there's different ways to instantiate it. So can everybody see my screen? Is it big enough? I'm going to type some letters in there so you can see. I could do that. I could do that to instantiate a dictionary. And I can also do this. Oops, I had a little space in there, didn't I? There we go. And then I can go ahead and do the type operator or type method to see that one. And then I can do that. And if I run that, you see I get 2 empty dictionaries. There's nothing in those dictionaries. If I, of course, got rid of the type method and just printed it, you can see that they're both empty dictionaries. So Tim, the command, it's a keyboard shortcut. So you can do on a Mac, you can do Option Shift and then the arrow down or up. I think down will copy it. So Option Shift and then down will copy whatever it is and put it down. And then if you want to move something, you just press Option and move it, and you can move it to different lines. So I can easily swap this by pushing Option, and I can move it up or down. I can move it up. It just, with code, it really helps. So it helps you work fast with code. You move whole blocks of code wherever. So that's how you instantiate a dictionary. Of course, empty dictionary is no good. You want to put some stuff in there, right? So here we have this example, a person, and I can also just instantiate a dictionary with data in it. And so in this case, I have person, and then I can go ahead and just kind of view it by calling underneath. And there's the data, there's person. And those are the key value pairs. Remember, when you have the curly brackets with that colon, you know you're dealing with a dictionary. So as you see them more often, you'll get more and more comfortable with them. And if I want to return just this name Alice in here, I would need to access the key. So if I want to return the name Alice, what would I need to put in these square brackets?
Name in quotations.
Yep. So I would go ahead and put name there, and I can run that, and now I get back Alice. And so this is a time when you use square brackets. It doesn't mean it's a list. When you're accessing a variable that is a dictionary, when you're doing this, you're actually accessing the key to return the value. And so you're not dealing with a list here, you're just accessing a key. And you don't access elements of a dictionary with numerical values like 0, 1, 2, 3, like you see the indexes of a list. These are unordered, so you have to use the key to get the value. So you use the key to get through the door and get the value. That's kind of how I remember it. And of course, if I want to print the age, I can do that. And now I get 30. Yeah, I would not even put index, like I would do not associate indexes with dictionaries. This is it's pretty good. Just remember you're looking at keys and values. And when I looked at the for loops, remember I kind of introduced that, how you would loop over a dictionary, because you still can loop over a dictionary. And how it does that is when you do the dot items, and I'll show that further down, the dot items method for a dictionary, it extracts all the keys out of the dictionary and gives you like a list type object that you can iterate over. So it gives you an iterable, then you can loop and see all the keys. So yep. So Tim's asking person, name, comma, age. Would that work? Let's try it out. Let's see. So like that's kind of how you have it in the text. And no, because it still associates it as one key. So that wouldn't work. Any questions on that? Instantiating a dictionary, kind of accessing the elements. Yep, it's not a parameter, it's a key. So a parameter is only for a function or a method. So yeah, just want to make sure we have our vocabulary correct, because when you start talking to other people, you want to make sure you use the correct vocabulary. So yeah, parameters for a function, the keys and values. Really just want to associate keys and values with dictionaries. Dictionaries are also mutable. So if we remember immutable versus mutable, immutable means it cannot be changed, but you can change it, but you have to redefine the entire thing. You can't just change one item like you can in a list, or you can access in a list, you can go access the third element or the third index, and then you can just reassign that index and it changes the list in place. You can't do that with a tuple. You can't do that with a string, which is another type of collection. Those are ordered collections. But you can change the value of a key value pair inside of a dictionary by just reassigning it. Not reassigning, but you're changing the value for the key. So if I were to change Alice's name, because there's like a typo, maybe it's supposed to be Alicia. So we can do, oops, make it capital. Person name, not Alicia. And then we would just reassign it to Alicia with a capital A. And when I run that, if I were to look at person now person has been changed from Alice to Alicia. So you can just access the key. If you want to change the value of some sort of key, you put the dictionary name, and then in brackets you put the key, and then you put the value you want it to change to. And that's how you change the value of a dictionary. You can't really change the key that way. There are methods to remove a key value pair. You would have to kind of rename a key. Just remember, keys have to be unique for each entry. So if you can only have one unique key in an entire dictionary, every key has to be unique somehow. That's why strings are used. Integers are used as keys. You can use tuples as keys because all those data types are immutable. And so you don't want an immutable data type. And remember, you can't change a immutable data type without just reassigning it completely. So if you remove a key, you're going to remove the corresponding value and you'd have to redefine it. Yep, no problem. So here we have some common dictionary operations. So, you can check membership of a dictionary. You can, I've already accessed a key value pair. You can iterate over a dictionary. We saw that as well. And so if you just try to put a key that does not, if you're like trying to access, maybe you're looking for the name of somebody and you don't really know what's in the data type. Let's say, for example, I were trying to access person and I thought there'd be a last name key. If I try to run that, I'm going to get a key error. And so you're going to run into this issue a lot, especially with some of the exercises we have, because if the key is not present in dictionary, but you try to access that key, it's just going to give you a key error every time. And so what you can do to see if something is part of a dictionary is you can look for a key inside of it by using the in operator. So just that will return a Boolean, and then you can run that into like an if statement. So you can say if name and person, do something, or, and if it's not, then do something else. That way you don't get a key error because you're just making a Boolean statement. So you could do something like last name and person. And if I run that, it's going to return a false. It's not going to give me a key error because I'm just checking to see if the key is in there. So when you're looking for something inside of a dictionary, it's going to default to the keys only. So if you're actually looking for the values, you would need to put values. And if you're looking for like a specific name, and I think I changed it to Alicia. So if I did that, then I get a true because it's giving me all the values in a list type object, and then I'm looking for that one term. Of course, if it's lowercase, it's going to give me a false because I'm case sensitive right now. So maybe you'd want to do something like that. I can't do that. First, I'd have to totally recast it. So I would need to do this list. shift. There we go. I think I can do that. List person values dot lower. I would need to iterate over it, actually. I would need to make a list, and then I would need to iterate over that list and look for Alicia. Yeah, I don't think I can do dot lower to the list. I would have to do it for each value. So I can do name list equals that. Let's not make it all caps. I'm having trouble typing today. And then for item in name list. That's why. I can do for item dot lower because I think it was a string. It was not a string. Let's make that a string just so I don't mess it up. Okay. So for item. Let's do for item name list. If item. You can do this. I can say turn or print. This is a really long way of doing this, but we can do this. Else. Try that real quick. Oop. Yeah, that. There we go. Let me see. For item name list. Okay, so I'm doing every item, and one of them is Alice, and one of them is not, because the other one is 30, the string 30. Okay. Let's make a new dictionary this time. Let me see if I have a good example. I think I have a good example over here somewhere. Yeah, here we go. Okay, my dictionary. I'm going to run that. So now I have my dictionary is set. If I want to see just the keys, that gives me all the keys. Conversely, I can do values. And I can see all of the values. If you notice, it kind of gives me this weird like dictionary values, and then it gives me like this open and close parentheses, and then I get my square bracket. This isn't a list, but it is iterable. So you can't use your list methods on this. You would have to cast it to a list first, and then you can do all the list values, which you would just surround it with the word list. And then you can use those list methods that you learned last week to work with the data if you need to. This is just a quick way to see your keys and values. And then, of course, we have one where we can see all of them. When I run items, now I get what looks like a list of tuples giving me each key value pair that I can then access. And so when you run your 4K comma V in my dictionary to items, what you're doing is every time that list or that loop iterates, K is being assigned to this one, and then V is being assigned to this one. You do whatever you do inside your loop. The next time it iterates, it goes to B and 1, and then it iterates, goes to C and 2, all the way down the line. So those are the keys, values, and items. Again, it's not exactly a list. It's a list type object that you would need to cast. If you want to do something with it or manipulate the data anyway, you would have to cast it to a list first before you do anything. Any questions on those three methods? Okay, we'll keep pressing. Okay, now we have let's go ahead and type this one out, the .get method. And I would need to put in a key if I know what I'm looking for. If not, I can also just put a default value. So in this case, I want to go for so I can run this. I get back a 3 because the key D is in there. But if I was looking for P and I run this, I'm going to get back a not found. So that's an easy way to search for key value pairs by key. You can then use your get method, and then you have a default statement if the key is not in the dictionary. If you notice here, I use the pop method. So my dictionary.pop, and I put the key of J in there. J is in the was in the dictionary, but once I did that, you notice it returned the value associated with the J. So it returned it and gave it to me in the output. But then when I called my dictionary again, the key value pair of J and 9 were no longer in there. Dan, remember that when you want to access a value, you have to use the key. And so that's, when you're trying to access data in a dictionary, you have to use the key to get the value. Now you can look at the values by using the dot values to see if it's in there as a value. But if you're looking for a value, you have to know the corresponding key to get to it. And it's going to be a bit to wrap your mind around. It took me a while when I was learning about dictionaries for it to finally just click. It's like, oh yeah, I have to use the key to get the value. And so I would really try to remember that when you're working with dictionaries. We have some pretty good exercises at the bottom of this lesson, by the way, that will really work on your dictionaries and accessing data. Did anybody already look at the exercises and try them? They were posted, I think, last week. I don't know if anybody ventured ahead and found the exercises in there. I didn't realize they were posted last week until this weekend. Okay, we're just going to keep on pressing through. You could also use the pop item to remove and return an arbitrary key value pair. I've never used this in my code before. I'm sure there's a useful, there's a use for it. I just haven't ever run into a situation using this, but this method here, I can go ahead and say my dictionary dot pop item. And if I were to run that, I would get back the I. In this case, it's going to the last one. It's supposed to be arbitrary, but I think with the newer version of Python, it's still going to kind of still give you some sort of like order, even though it's not really ordered data collection. It will pop the one in the end, whatever is displayed. But in this case, the pop item will remove it. And if I were to look at it again and run it, the I is now gone, so it removed that key value pair completely from the dictionary. I'm going to go back up here and just make sure it's reestablished back in its original form. And I'm going to make another dictionary. And we will do okay. All right, this other one is update. And what this is used for is to take it's like to merge two dictionaries together. And so it use update one dictionary with another dictionary. So we're going to start off with my dictionary and use the method on that one. And then put in my second dictionary. And then if I were to run that, now I have at the end, I have K and L from my second dictionary inside of my original dictionary. And so I have them all. Any questions on that? It really doesn't sort them. And, I know it looks really like pretty the way that it just like IDEs and Python in general is getting better at just presenting data in a nice way. But I would really urge you to think about this as unordered. So it doesn't matter that the D is first and the D is in the fourth position. It doesn't really matter because they're just key value pairs. So it could be totally out of order. In the exercises though, you're going to see some of the data it returns. There's a reason why they don't have there's a couple some of the exercises have the checks where it gives you the true or false if you got the answer correct. One of them just has the data, and then it's just having you go look and see if what you got matches what the desired result should be, and there's no automated check. And when I did it, my result ended up being not in the same order. So, but it doesn't matter because it's just key value pairs. So. Diego's asking, is there a way to record the key value pairs that get popped and be able to use them? Yeah, so when you do the pop item or the pop, look how it's returning. So you could actually just make this, you can make this a new variable. So you can make this discarded data, and you could then make it equal to my dictionary.pop J, and then it will give you the 9, and then now your discard data equals 9. You can do something with it, whatever you need to do. So you are recording it, and you can put it into a list. You could do all sorts of stuff at that point. So yeah, when it returns something, and that's kind of what it says here. It says remove the item with a specific key and return its value. when it says that, it means it's going to give you something back to do something with. So. Yeah, and Philip said it pretty good. Just, remember that arrays and lists are ordered and dictionaries are unordered. Same with sets. Sets are also going to be unordered data collections. So, and I'll give you a good example of why it is. So, I find myself using, it all really depends, but lists and dictionaries are my most common when I'm doing stuff, whether it's web development or even machine learning. I'm usually using a dictionary or a list to collect my data when I'm processing it. And you have to remember the types for each one, or the methods for each one, and how you're going to move data from one spot to another. Changing data forms. That's really going to be the foundational learning of this course. Really kind of highlights that. And you should be striving to be able to take data from a dictionary and then collect it, process it, use it in a list. Change its form. That's really the goal of this, is to get you to that level, because that's where they start with Whiskey Platoon. You have to have some sort of base level knowledge, and that's what this is getting you to. So give me a second. Yep. Dictionaries are like JavaScript objects. I mean, dictionaries are objects. We just call them dictionaries. But yeah, they're like JavaScript objects. Mm-hmm. All right, this last method. And I run that. I get back my empty dictionary. What would happen if I were to run this cell again? What would I get back? Now that I've run this cell and I cleared it, if I were to run this one again, okay, so some nothings, empties. Again, K and L pairs we put in. The OG list, the OG dictionary, I think it's going to go back to the way it was before. If I run it, I only get the K and the L because I cleared it here. And now my dictionary in memory is empty. And when I update an empty dictionary with another second dictionary, which I haven't touched, I'm just putting the items from that second dictionary into my dictionary. And so I just get K and L. All the examples I showed you here in this Jupyter notebook are right here as well. So this helps you kind of see, in this case, we have Alice, and you're getting the keys and values. All this stuff is available, to look at. And this kind of highlights how, how they work. This is a pretty good little example. Nika, were you wondering why you came back with K and L? So I ran this last. So when I ran the clear function or the clear method on this dictionary, it ended up as a empty dictionary, and that's what came back. You see, when I called it, I have an empty dictionary. So when I run this cell again, okay, this Jupyter notebook does not go in order. If you take a look at the numbers, that's actually the orders in which I ran the cells. So this little 32 here is the 30-second operation I've run on this notebook since the kernel has been active. And then I ran this cell again because I wanted to show the update. So this was the last thing that happened when my dictionary became empty. And so when you run my dictionary again, this is an empty dictionary, my dictionary. And I'm updating it with the contents of my second dictionary, which has not been cleared. So it only contains K and L. And so over to update an empty dictionary with a second dictionary, I'll just get the contents of that second dictionary. Yeah, that's one thing about Jupyter Notebooks is, you can run cells in any order. And so if I want to go back and get my original dictionary, I can just go back up to cell and run that. And now my dictionary is back the way it was. And if I ran this now, I get it all back because I set it in memory as the original dictionary I initially made. The keys must be unique. The values can repeat all day, but the keys have to be unique. Let's just see what happens if I made a dictionary with repeating keys. Let's just copy this over so we can just quickly put the text in. We'll just do that. Yep, I'll go over that, Diego, in just a second. If you look what happened, it didn't give me an error whenever I assigned, I made this whole thing here, but whenever it was created, it saw that B was used twice. And so it just used the last time I put whatever value in. That's why B is now 25 whenever I call it, and I don't see the 1. And so that shows that your keys have to be unique, but the values can repeat all day. So I can make these all 2. Like that. And if I run this, I have all 2s for the values. The keys are unique, and then I still have 25 because this one got overwritten by this key here, or the value here. Yep, it just overwrites it. Just like if I were to go in here and reassign a key value pair. So if I were to say my weird dictionary at the key of D, capital D, and I say equals 700. And now if I print it, or just call it again. Now it's 700. Even though I defined it initially with a 2, I reassigned it. That's kind of like the same thing as what you're doing. So. So Daniel's asking, what if you have names for the keys and you have 2 people with the same name? Do you just make one slightly different? Like Joe A and Joe B? Well, you really wouldn't store names as keys. Right. So you could give like a unique user ID, which like is going to be unique for every entry in your entire dictionary or database, if you will. You would typically have a kind of like a small dictionary inside of for each person. So for each unique ID, there would be a smaller dictionary with first name, last name, address, wherever else, right? And that would have that user's information for that key or for that ID. And so it would be structured a bit different. I can give you an example later on, Daniel, of what I mean. If you were to organize, a bunch of people, you wouldn't typically use their names as a key. You would just use first name, last name. So first name would be the key, and the value would be their first name. Last name would be the key, and their last name would be the value, so on and so forth. Diego asked if we can go over one more time the dictionary methods, what it means by default in the dictionary get and dictionary pop. So I showed that with the dictionary get, I believe, right here. So I said, hey, in my dictionary, I want to get the value to the key of P. But I mean, we can see this dictionary and we can see that the key of P does not exist. And I can run that. What this default is just it's kind of like a failsafe, so I don't get an error. And this is say, hey, if I don't have this key, I just want to bring back not found. That way I don't get an error. Now, what if I were to get rid of that though? Run that. It wouldn't give me anything. So it's an optional, this is an optional value to give you kind of like a kind result that you're looking for, unknown or unfound or something like that. Yep, so it's just default value, just something you want to put in there as a failsafe. Print which dictionary? Which dictionary? Oh, print that one after I do that. Okay, so you're talking like right here after I run this. It's my dictionary like that, right? Let me run it here. Oh, wait, let me run that real quick. Now run that. Okay, so it doesn't do anything. So I run my dictionary, I define it as this. If I try and get P, it's not going to do anything if I don't have that key, and then it won't remove anything. Is that what you're asking, Athena? Oh, you're saying to put like the default statement back in there. Like that. So run that. It's not going to do anything. Now, if I were to, let me see if I can print that, because the reason you're not getting the statement is because I'm not printing it. I think I can run that. Yeah, there we go. So if I were to print the statement because I'm putting a statement below it, now you can see the not found. No, it wouldn't insert it. Mm-mm. Any other questions on dictionaries? I know we got a little bit of late start, 15 after, but let's go ahead and stay on the break schedule. So let's take a 10-minute break and we can come back at 7:10 or 7:11 and we'll resume with sets. I'll probably stay in the room anyway. So if you have any questions or anything like that, I'll be more than happy to answer them during a break. I'm going to pause the recording. So that's something to think about, when you're doing something like this. This is very unfamiliar territory. Like never done this at all before. and you're going to feel challenged. You're going to feel discouraged. You're going to feel like you don't belong. There's a lot of feelings that happen in coding, and I get those like to this day. I'm always doing something new, and I can go on and on about consulting work, because that's what I do. As you know, I work in consulting, so I'm working on new projects all the time. And I've done everything from, just full stack web development to machine learning to dabbling data science. Now I'm doing a front end application with React and TypeScript, and I'm also doing machine learning, and it's all new to me. And so those feelings, they call it imposter syndrome, and it's a prevalent term in our industry. And you'll see it if you're on LinkedIn at all or anything else. You'll see posts about it. Code Platoon has a whole section on it. They'll talk to you about it. It's a real feeling in this environment, because you're learning how to code. I wouldn't call it imposter syndrome for sure, but it's, wow, this stuff is kind of difficult, and I have to get used to this, and I have to practice. I would classify imposter syndrome as like, if you're like, I'm already doing the job and somehow they hired me and they're paying me to do this job, and I feel like I can't do this. Like, I don't even know what I'm doing. I've been there, and I'm like, how are they paying me? Like, I don't even know how to parse through this data. And then I realize, I look back at my work that I've done, and I'm like, oh wow, I totally took that code and I created KML files from this, GeoJSON stuff. And like, when I look at all the small tasks I did to get there, it took a while, but I did it. And those small wins when you finish these exercises, when you finish, something else, or you actually get one of these scripts to work, and you're like, whoa, got it to work. I didn't see any errors. Celebrate those wins and realize you are learning something. So you're not alone. So just keep that in mind. This stuff's difficult. And whenever you're, if you're in Whiskey Platoon and you're in the thick of it, you're in your one of your exams, and you're trying to finish the stuff, and it's really, you're really feeling the pressure. It's okay. You'll get through it. So yeah, I'm pretty sure you're feeling overwhelmed, because this is a lot of new information. It really is. But just take it one step at a time, and know that you always have the references. You always have Google. You always have your references. These you can, if you have a GitHub account, you can clone this entire repo and get all the stuff onto yours, so you can mess with this data if you want to. You take a look at a reference if you want to. I find Google is the best way to reference things, because you can always just put in the word Python and set methods, and it will give you all of them. You can usually get one of the sites that has all the set methods. So yeah, don't worry about feeling that you're out of place or you're behind, because you're not. You're in a very foundational course right now, and you're being exposed to the very basic data types, and it's going to be all unfamiliar. It's just like the nouns and verbs of a foreign language, and you're just learning them. So you're not going to be able to, like, for some reason every one of them talks about, like, adding and removing, and these that's the same thing as, like, biblioteca or el baño for bathroom and library. For some reason, we got to know where the library and the bathroom is in Spanish. You're gonna get, you'll see these over and over again, and you'll get used to them. I promise. And if you don't get used to them, it's okay, because you always look them up. So enough about that, though. Let's move into set methods. And if you have any other questions about that stuff, imposter syndrome, that stuff, if you have any questions, please feel free to reach out to me. If you don't want to ping me in the main room, you can always ping me, DM me if you need to, or the TAs as well. We'll all be happy to answer your questions. So it is all right if we're going back and looking at the old challenges to help complete newer challenges? Yep. If I didn't say you couldn't do it, you can do it. and these are all open book. I mean, in a coding job interview, you're allowed to ask the people giving you a challenge for help, and they'll help you. And sometimes that's exactly what they want to see, because they want to see if you know how to ask for help, and they may give you the job. And so, yep, you can go look back at the stuff. You can ask questions. That's all part of it. So you're free to do a lot of things when it comes to these coding challenges. And we're not grading these coding challenges. So these are for you just to practice on and see what you can come up with, and then ask questions as needed. So
Write a function with 2 arguments that will return an array of the first n multiples of x. Assume both the given number and the number of times to count will be positive numbers greater than 0. Return.
need to find who is unmuted. Got one there. Okay, I think I'm all muted now. All right, let's move into sets. It's not going to be as involved as dictionaries. It happens. So sets, really, I mean, if you look at sets in general, I mean, it's a pretty small section here, but sets are going to be unordered collections of unique elements, and you can almost think of them as, hey, this is kind of an unordered collection of just keys, because really, that's what it is. And it's nice because you can use sets to come up with answers to certain things, like, it will quickly tell you, like, if you have a list of 10,000 names, what are the unique names that I have? You can just cast it into a set and you'll magically have every unique name in that list. Now, if there's misspellings, then they'll end up as a unique entry, but at least a good first look to hey, how many unique numbers do I have in this list? They're created, and the only way you can create an empty set is using the set constructor. So let me go back to lesson 6 here. Yep, Philip, that's yep, I do it all the time. Now, I've been teaching sets for a bit, so I have some of them at least memorized. But yeah, you just don't use sets that often when you're coding. Typically, you're going to use dictionaries or lists, tuples. If you're in like geospatial stuff, which I'm into, I use tuples quite a bit. But those are really going to be your main data collection types, and of course, strings. Strings are everywhere. So if you look here, I have a set, right? So if I want to say let's say my awesome set equals, the only way I can instantiate a set that's empty is with the constructor method. If I try and do it, this way, if I try and do it this other way, I will not get a set. It'll default to a dictionary type. So because, I think just it's a design thing, dictionaries are more prevalent. So why the heck would I make that the default for a set? Because they use the same curly braces, just make the set constructor. But you can also, if you have a list of something you want to cast it to a set, you can always just cast the entire list to a set as well. So it doesn't have to start as it being empty. But if you need empty set initially, this is the only way you're going to get empty set starting out doing that. So of course, you can instantiate like this fruits example here. So I'm going to go ahead and get rid of all this. Put that in there. And then, oops. I can run that. You can see you get apple, banana, cherry back when I call fruits. And it is a set. And you can tell it's a set because it has these curly braces and there are no colons. It's just commas in between each entry. So this is a set. If I want to add an element to the set, I can use the add method. And I will add pair. If I run that, now I get pair added to the set. When we're looking at checking membership, you know, I have a, let me go back to lesson 5 real quick. I'll just copy this, this thing right here. I'll go into lesson 6. Okay. Okay, if I were to run this, I have 100 items in my list. I can print the list. When I do this, of course, it's gonna be a little different, but that's fine. It's just random numbers, random numbers. So I use this little loop to make a list of 100 items, and it's just a pseudo random. You know, it's any number between 1 and 500. It's a library you can pull in from Python. It's already included Python. You just have to import it to use the methods, and it's random.randint, which is random integer. And this will tell me kind of what I'm doing with it. But so if you take a look at that, I have you know, I have my list here. And then let me go ahead and make a few more code blocks. I'm about to show you. That's what I was going to do here. So, so I have my list, right? And I can say, well, I want to my num set equals set my list, and I can print len my num set. Now, if I didn't get any repeat numbers, I'm thinking I probably did. But I'm going to print that. And I'm going to print the length of my original list. Print len my list. Okay. Okay, so if you look, the length of my list is 100 because I have 100 items in there. But the length of my num set is 93. And all I did was cast my list into a set. And what that means is I have some numbers that repeat in here because a set will only have unique items included. So if I were to cast any list with repeating stuff, just like I talked about 10,000 names, and you cast it to a set, you'll get only unique names. The same thing happens with this list. I'm going to take this list, I'm going to cast it into a set. I will only get the unique numbers in there. So, and the reason sets are they're considered unordered collections of data. So if I have repeating numbers here, which I did, I had 7 numbers in there that were the same and they were removed. So let's say further on down the list, there were 2 486s, right? So maybe there's a 486 like here or something. Whenever you get the set, which 486 did it remove? How do you know? That's what makes sets unordered, because there's really no way to tell, you know, which one it grabbed. It could have been any of them. But it pulled only one of them and put it into a set. So that's why it's considered unordered. Any questions on sets? Oh, is there a way to return the 7 numbers that got pulled out? I don't think you can with casting. But you could, you know, I mean, you could go back and loop through. So if I were to, you know, figure out which ones were, you know, were pulled out, I could do like a loop over this list for every item if it's not, well, no, because it'll be in the set. I would have to loop over the list and see, you know. My num set minus my list. Yeah, it's duplicates though, so it's only going to be duplicates that are pulled out. So
I guess in this case it'd be kind of just wondering to find out what numbers are not the unique ones, which is why they got pulled out. If it's like 1,000 numbers, you know.
yeah, I mean you'd have to. I mean, you'd have to. Yeah, there's ways to check for membership. You know, off the top of my head, I'm sure there's something, but I can't. I can't remember. I can compare. So some of these methods we're going to talk about are comparing sets to other sets, but not lists. So yeah, you'd have to. I mean, you'd have to look for repeats in your list. By you could loop over your list, and for every item in your set, you remove one item if it matches, and then at the end of your loop, you'll have the 7 left over that are extras. Because if you loop over the set and just pull that number from the list, it'll only pull it once. So you can loop over your set and then pop that item out of the list or remove it, wherever the method is. I can't remember off the top of my head. I just taught it last week. But you can use that method to pop it out of the list. You can pop it, I think. And then once that set is done looping, the 7 that you haven't popped out of the list are the ones that repeated. That's how you,
Okay.
yep. So I showed you how to add. Removing is the exact opposite. You know, you do set dot remove, and then you put in the value, the element in there, it'll remove. And just like a dictionary, if it's not in the set and you try to remove it, it's going to give you an error. So it's just the same thing as with those keys. Like I said, like the set members are kind of like keys. They just don't have a corresponding value. So if it's not there and you try and remove it, it's going to give you a key error. So if I were to say my num set dot remove, and I know for a fact the number 501 is not in there because it only went up to 500. If I were to try to run that, I get a key error because 501 is definitely not in there because I want to go up to 500 in my loop. Discard, I don't think gives you an error, but it's not going to remove anything if it's not there. I don't know if this one also has the same kind of set with the dictionary. Let's see. I don't think this one will work, but yeah, it only takes one argument, so it doesn't work that way. What's nice about IDEs is that you mouse over it, it kind of gives you like a description of what that method is. So here it just says, unlike set remove, the discard method does not raise an exception when an element's missing. So really the only purpose for discard is to be kinder if you're trying to pull an item from the set without giving you a nasty type error. I don't think so. So dot remove, right? So yeah, this says remove an element from a set. It must be a member. If the element's not a member, raise a key error. It's not going to give you the option. I think it only allows one parameter. So you can't add the second parameter in there. Okay, here we have pop. We can run this one. And it popped out the number 13. That's super lucky. We can keep running this. And it's gonna pop out. If you notice, it's like it looks like it's going in ascending order. And it says it's arbitrary. So part of me thinks that I think with newer Python, it's not exactly pulling arbitrary. I'd have to look into the reasoning for that. I wouldn't worry too much about it. I've never used pop ever in my job, but that's what you would use it for. It's remove and return an arbitrary element from the set. Of course, we have clear, which just like with the dictionary method, if you run that and then try and look at, let's say I try and pop another one. I get a key error saying pop from an empty set because I cleared it. So my num set now doesn't have anything in there. Run these two and I get my list back. And it looks like again, I only had there we go, 92, a little different. So I'm getting about 7 or 8 multiples in my list of 100 items. Any questions on the method so far? Okay. I'm going to add more code blocks. All right, I want my list to equal something which it already does. And then I want my, let's see, let's just do 10. Let's do 1 to 1,000. Run that. It's a little more digestible. And then I'm gonna have my set. Oops. Set. My list. My list. I need that. Well, I guess things will print it. My other set will set list. Okay, cool. Oh no. Let me just do it this way. Let me run this again. Forgot to run this before redefining it. I can do it this way though. Cool. Okay. So if I were to run this, now I have let's just change some of these. Make sure we run this again. Yeah, more. I can comment that out. Oops. Put this in here. I don't know what that was. Let's try that again. Command C. Sorry, give me a second. This. I don't know what's going on. Why I can't copy this. There we go. Now I can run that. Okay, now I have two different variables, my num set and my other num set. I think I do anyway in memory. Okay, yep, I do. Okay, cool. There. All right, so now I have two different sets, and I wanted to kind of use this to kind of illustrate these other methods. And what I wanted to do was let's go ahead and change. Let's see, my num set. Okay, so let's change this one here to be equal to the other one. So let's do 740. Let's have another one. Let's have a 879. Okay, cool. Okay, if you look at these two sets, you can see that I have a couple of values that are the same, 879 and 740. Now, yes, we can see that on here, but you're working with bigger sets, you won't be able to necessarily see that. So we have these other methods as well to kind of show how we can extract. So if y'all have seen those like Venn diagrams before, and I have a pretty good example of that. I think it's this one. Let me see. Yeah. So looking at this graphic here, in this case, we have a breakfast set and a dinner set. And they're illustrated by these circles. Okay, if you take a look at these two circles here. So I necessarily would not eat like Pop-Tarts for dinner, but some people do. So the first method I wanted to go over is a union, and a union is just grabbing everything from both sets. So it's like wrapping around. So these the Venn diagrams showing those circles that overlap. It's exactly what these methods are doing. A union is going to just take everything and mash it together into one big set. So if I were to take that and do my num set dot union, and it's my other. I'm going to get everything together. Now, it's only going to have one of the 740s, and it's only going to have one of the 879s. But it's going to be everything together in one set. So it's everything common to both of them. Conversely, we have intersection, which if you remember from the graphic, we had like that little football shape in between the two circles. The intersection is only going to contain elements that are present in both sets. So seeing as I manually change that, you kind of know what we should get back, right? What would we get back if I ran that? Anybody know? If I were to run intersection on these two sets, only the matches. If I ran that, I remember I manually changed 740 and 879 to make it common to both. So if I ran intersection, it's only going to give me the two that are common to both sets. Yep. The next method is difference. And this one returns a new set containing elements that are in the set on the left, but not in the other set. So, so in this case, I want to return the values that are only in my num set, but not in my other num set. So if I were to here, $740 and what was the other number? 740 and 879 are not in this list because they are also in my other num set, so I don't want to include them. So that's the difference between my num set and my other num set are these numbers. That's what I get back as the difference. And lastly is symmetric difference. This one returns all items except for the ones that are shared. So 740 and 876 will not be in that value. So if we go back to the graphic, the symmetric difference will be everything but this football shape. So everything on the outsides. Any questions on those examples, the set methods? In the markdown file, we have some other examples here with fruits and more fruits, and you can use union or intersection. You can test those methods out with some of these examples, and feel free to do that. That's it. That's the lecture on dictionaries and sets and the associated methods. These aren't all of them. There's more, but these are the ones you're going to most likely run into. And it'll be more than enough to set you up to complete any coding challenges that you'd face, getting into Code Platoon. Are there any questions over anything I talked about today before I go over the conclusion and then the exercises? Okay. So in conclusion, we talked about dictionaries first. Dictionaries, again, are key value pairs that we would use to, it's an unordered data collection. Very powerful, very prevalent throughout, any type of programming. You're going to be using dictionaries. It's a great way to store data. But just remember that you have to use a key to extract a value. And it's a bit of a challenge to wrap your mind around that, especially when you're starting out. But after a while, using it enough, it becomes second nature. So please keep practicing. the whole goal of this is to really show you all these different ways of storing data, and then letting you explore ways to take that data and maybe change form, do something else with it, use these different tools that we have. We're really kind of over exploring, new data types. We're not going to go over any more new data types. This is it. We've gone over dictionaries and sets. We've gone over lists and tuples. We've gone over all the native data types. We have strings, integers, booleans, floats, and this very basic level of Python programming. It seems basic, but it's actually quite complex. You have lots of new ways to look at computing, to look at problem solving, and these are all your tools. So these are the wrenches and the screwdrivers in your toolbox. How you use them to do what you want, to build the things you want. That's really the goal of this, to give you that toolbox and let you explore using those tools. With that, we have 4 assignments. And so I'll go ahead and open up some of these so we can take a look. I gotta remember to do it in the... Nope, I totally right-clicked and did not register as a right-click. Let's go back and try that again. There we go. This first one is write a function that takes in a string of lowercase characters and returns an object or a dictionary containing the count for each letter in the string. So this one here is going to introduce kind of a way to use dictionaries to count. It's pretty prevalent, and it's really important to kind of know how to do this because you will be doing it sometime. And if you dive into software engineering and you get through code Platoon, you're going to be doing something like this eventually. But this is the way to do it. So really, once you take the string, and then you're going to just count the characters. So when you run into a B or a D, you'll then want to put a corresponding number next to it in a dictionary, and then return that dictionary. That over. Yeah. The second one is the car trip. And so this one here is it's pretty cool. So it gives you a car object. So the object is going to be a dictionary, and the dictionary looks like 3 keys in there: people, miles, and spare tires used. And the values, the people is a list of how many people are in the car. In this case, we have Spider-Man and Batman, and we have 1,500 miles in the car, and we have used 0 spare tires. And then the second argument or parameter in this car trip function is miles driven, and it's saying 5,500. And in the text up here, it says update the car object to include new amount of miles in the odometer. So you'll want to do that when you get, so you want to update your miles key to reference, however much 5,500 plus 1,500 is. And then it says, additionally, the road's very rocky, so you'll need to use an additional spare tire every 1,000 miles. So you have to figure out how to do the math in a function to update that spare tires used based on how many miles driven on the rocky terrain. So this was a pretty fun one. I did this one as well. I think you'd like it. This one really gets into how would you use the data you have to update different keys on a dictionary based on the restrictions that you're given in the rules. And Athena, yeah, we during the last hour, we can go over last week's homework. We can look at other stuff as well. We can look at other tools, whatever we want to talk about. And we have our TAs here. I can't remember who. I know, Philip's here. Is Tyler, right? Is Tyler here too? And I don't think Mike Zira was going to be here this week. So I think that's it. You're it, Philip. Oh, Tyler's here. Okay, I didn't see him in the it's hard to see the participants. So Tyler is here. Cool. So we have 2 TAs here to help. And we can do a breakout room. I think we have some breakout rooms already up. This is like the main cohort Zoom channel. So if not, I can always make some if we need some. This next one here is how much will you spend? It says given a dictionary of items and their cost in an array specifying the items bought, calculate the total cost of items plus a given tax. If the item doesn't exist in the given cost values, the item is ignored. So here we have our function. Again, we have this password in here just so we can, not get an error when we try and run it initially without putting data in. But then we have looks like we have a dictionary because we have our open and close curly braces, and we have the colons in here. So we have some items. We have some socks, shoes, sweater, shirt, pants, and the different prices. And then it looks like we're given so we have our costs, we have our items, so whatever items that we actually want to purchase. So that's given to us in a list. So items will be a list, and then tax is this number here at the end. Just note that this is not a percentage, which I thought it was initially when I did the problem myself. So this is just a straight up value add. So you don't have to worry about multiplying like a total times this and adding that to your total. This is literally just add this to whatever total is. It's the total in cents, not a multiple. I was like, wow, that's a 34%, or 300% tax here. That's crazy. When I saw that, I was like, wait, I think they want me to add just the total in here. So note this line 5 here, output should be rounded to 2 decimal places. So just make sure that you look up how to do that. You can literally Google Python round 2 decimal places. I think you would come up with a good result. And the last exercise, which can be a doozy for sure. And this one here is, if you look at it, there's no like check, if you will. It's kind of like you just need to take a look at the solution data here and see if it matches. That's what I did. Because it was out of order, because it's not ordered. It's all dictionaries. Well, it's a list of dictionaries, but your list may not be in the same order, so you may not get the right result. So anyway, the description is you're a new programmer at your company. Your CFO needs some data regarding all the employees. Your CFO needs number of employees per job title and the average salary for that job title. The average bonus that job title receives, and the average total compensation. So you're given an array of objects that represents all the employees in the company. So you have this employee data. And if we just put our, okay, how am I going to solve this problem hat? When you're looking at this, you're like, okay, what's my data coming in? I'm trying to get some data coming in, and then I want to put data, I want data to come out looking like this. And you look at this, like, okay, well, what types of data do I have here? Well, previously we went over lists, and this says employee data. We're assigning it to what looks like an opening of a list. So this is a list, and then inside the list, each element is a dictionary. So the dictionary is, it has name, title, salary, bonus, and this next dictionary entry has name, title, salary, bonus. So we have Joe, developer, and then 125, and bonus 15. And then here we have name, Kelly, title, developer. If you notice, and this goes back to who was asking the question about like how the names would be different. I'm going back up in the chat. Oh, we got a message finally. Daniel. Okay, yeah. So if like you had two people with the same name, like we could have two people with the same name here and it wouldn't do anything because they're completely different dictionaries, but the keys per dictionary are the same. So you could have two Joes in here, but they have other different attributes, like, you know, a different bonus or a different salary, a different unique ID. You could have a, you know, employee ID, which will only be unique to one person. Like you could have that. And each, the uniqueness comes from, it's within the same dictionary. None of these keys in this dictionary are the same. They're all different. But from one dictionary to another, they are the same. And that's important. You actually want your data structured that way. If you're looking to combine it and get averages and other things, you'll want the keys to be the same so you can then loop over this and grab the data you need. And so this one here is it's a bit of a challenge. I am sure a lot of you are not going to be able to finish this one, and that's fine. But this is a really good way to stretch how you can solve this problem. You know, how am I gonna extract out, you know, well, the CFO wants all developers, then he wants, of these developers, how many developers do I have in this list of objects? And then what's the average salary and the average bonus? So that's dependent on how many I have 3 developers. So actually I have 3 developers. I have, you know, and this is, if this list was, you know, 10,000 employees long, you couldn't just look at this and do that. But here, you know, we have 2 designers and 2 product managers and 3 developers. So you have to do an averaging operation for developers. You know, you have to have 3. So you have to like add up their salaries and divide by 3. That's only for the developers, not for these other ones. How do you keep the product manager out of developers calculation? You know, these are things to think about when you're running, you know, a Python script. So it's a tough problem for you guys, and that's good. It's gonna stretch your, you know, the way you're thinking using these tools. But I highly recommend you give it a really good go. And do not hesitate to ask questions in the chat. If you noticed, I've been pretty active in the chat. Same with our TAs. So if you put a question out there, and other students, put your question out there. I don't care if the question is like, I don't understand strings, ask it, because we'll be happy to go back and revisit. So this one is a tough one. You end up with, this is what you're supposed to come up with. It's another list of unique dictionaries, but the dictionaries have the same keys for each one. And then you're breaking it down. So you have 3 developers, 2 product managers, and 2 designers. You're getting average salary, your average bonus, and then your average total compensation. So this one will be a tough one, but it's a fun one to do. So with that, I'll stop the recording now, and then we can move into kind of like the office hour, if you will.